Okay, sorry, this is not day 3, this is day 2. Okay, so what we are going to work on right now is load or sample data set of June 2015, like we did yesterday, and run the classification of with Seagrass Mapper user's manual from page 18 to 23. If you want to do the same exercise using Seagrass Trainer, our Chinese colleagues, because you cannot access Seagrass Mapper, please use Seagrass Trainer analysis tool instead of using Seagrass Mapper. Seagrass Trainer have a mapping tool function after you push the analysis tool button. Okay. Let me recap the procedures of satellite image analysis in Seagrass Mapper. This is a flow. You have, you might have your own satellite image, or you have satellite images in GEE data catalog. And then you select these satellite images, and you also specify area of interest you are working. And you have training data set ready, you have depth data, and then you work on image correction, just Dr. Sagawa explained earlier this afternoon. And then we do image classification, and then you get the classified result. So this is a basic flow. And the procedure of satellite image analysis using Seagrass Trainer with Seagrass Mapper. We use Seagrass Trainer to give our order to Seagrass Mapper and return the result. This is the case if you are based in China, you have no access to Seagrass Mapper. And if you are not based in China, after giving the order to Seagrass Mapper, you can just work on Seagrass Mapper to get the result. Okay. In Seagrass Mapper, as we learned yesterday, there are parameter setting panels on the left side of the screen, and you see the result in the middle section of the screen or right section of the screen. And everything starts with reading asset in Seagrass Mapper, as we learned yesterday. And in this exercise, we will be using sample Nanao 1506 dataset. Or you can use your own asset if you have succeeded in uploading the asset. Okay, now I would like to explain the detail of each section. First, you need to select satellite image. In this case, sensor name is selected Landsat 8 Tier 1 TOA reflectance data. And I assign 2015 June 1st to present, because I know the data set I created is based on June 2015. And in this screen, I selected the June 1st image. And I was specifying the cloud coverage. So you can change these parameters. And if you just want to select no cloud data, you need to change this slide bar to the left. And the band ID is the automatically granted if you choose the data set available from Google Earth Engine data catalog. But if you are uploading your own data set, you need to specify the band numbers according to the sensor specifications. This information is usually comes with metadata information of the satellite image, and the band combination is different by sensor by sensor. Okay, setting atmospheric correction parameters. This is a typical setting that I recommend. You need to take mask for land option because you are not interested in, there is no seagrass or seaweed on land. So it's definitely recommended to mask land. And atmospheric correction, this checks box number 4 is when you are conducting atmospheric correction. This has to be ticked. And The number 3 in the middle is, as I explained, this option is for very clear water in a tropical zone where the transparency is very, very high. So if your case study area does not have the high clear water, it's better not to use this option. So this is my typical setting in the template zone, just checking number 2 or 4. And for atmospheric correction method, dark pixel method is given by default. If your image that you are working on has some sanguine effect or some of the brighter pixels, it's better to use near infrared model method. Setting water depth correction parameters. In the case study that I presented in Nanao Bay, I was masking area deeper than 10 meter because I know in Nanao Bay, seagrass does not grow under 10 meters subsurface depths. This is because light cannot penetrate into such deep water by the turbidity. So by experience, I know that the seagrass does not grow under 10 meter. So in this case, I type 10 meter here. In case of the Toyama Bay, which has higher transparency relative to Nanao Bay, I use 20 here. So this number depends on your case study site. Okay, I think there was a question about tidal collection. Okay, in Seagrass Mapper, there is an option to do a tidal collection. In this case, you need to upload a tidal data set into the cloud and specify that tidal data station code in this box. By default, there are data sets available from Japan Meteorological Agency if your case study site is in Japanese seawater. And most of participants here, I think, outside Japan. So you need to prepare your tidal data set that matches your case study site. And how to do that is explained in appendix of the Seagrass Trainer Seagrass Mapper manual. Water column corrections. There are two options here. Depth invariant index or bottom reflectors index method explained by Dr. Sagawa. So if you want to detect seagrass in deeper water, this option is definitely recommended. And also, I hear the BRI option is useful for relatively turbid water. So it's nice to try this option and do the comparison with the result not conducting water column correction. At the end, you need to specify the number of classes. In this example, the class is specified as 4, and supervised classification is checked, and the model random forest is picked. And sampling scale is set to original, means the same as satellite image resolutions. And the training rate here is about how you, how many percentage you want to use to train the model, and how many percentage of the training data you want to use it for validation. So in this case, 70% of the data is used to train the model to estimate seagrass habitat, and the remaining 30 is used for validation. Training data split by each class is about how you select the this 70 to 30. If you don't check this box, the Seagrass Mapper will randomly check the 70 and 30, regardless of the sample substrate class you have defined. Majority field size is about smoothing the image you will be getting. And after you set all these parameters, you hit the run button, you get the classification result. So in this hands-on exercise, we will be using the sample dataset asset, and you will be examining the options. You will be changing the options here to see the accuracy, the changing accuracy assessment result, and also the changes in area calculation result. Okay, and before ending, I would like to explain a little bit about accuracy assessment. This explanation was already done by Dr. Sagawa, and for me, this was at the beginning very confusing. And then I was trying to find a good explanation for my colleague and also myself to understand. This is in Dr. Sagawa's presentation. He called it reference data, or it's actually a training data set. And this direction is about how the model classifies the pixels. And it's really important to imagine two different maps in your head. What comes from the real world is this direction, and what's predicted by the model is this direction. Okay. And he was mentioning about producer's accuracy. This means how well producer's accuracy is calculated by this direction, and this means that how well can the situation on the seafloor be mapped by the model. And on the other hand, this direction is about, it's called user's accuracy, and it is about how well the predicted class matches on the seafloor. Okay. So now we will be working together with the sample asset. And before doing that, I have one additional explanation. Let me switch to another screen. Please hold on a second. Okay, now I think you see a screen of a Seagrass Mapper. And this is different location. This is our western section of Toyama Bay, where we have Seagrass habitats. Okay. And in this exercise, oh, sorry. Okay. Yesterday and today I said reading the asset or registering asset has to be done using Seagrass Trainer. There is another way to do it, is to read asset information that is associated with your personal Google Earth Engine account. This asset here is associated with my personal account. Okay. Now I'm logging into a code editor. Genki 007 here is my personal Gmail account. And I have asset information created sample underbar HIMI 18007. So here you can directly upload the AOI data, area data, depth data, satellite. Well, in this case, I have uploaded worldview 2 associated with the parameter data, the metadata, and training data set for atmospheric correction, and training data set for substrates, and the training data set for water column collection. So there is a way, another way to read your own asset associated with your personal Google Earth Engine asset folder. Okay, and this is our example of 1, 2. In worldview 2, red band is band 5, and green band is band 3, blue is band 2. And the near infrared is stored in band 7. And I will be masking area deeper than 20 meter, and I will be testing DII and running the classification of the seafloor substrate in Kimi area using worldview 2 satellite that satellite image that I upload into the cloud. So this is another way. Okay. Okay. I see someone's raising a hand. Okay. Elijah, unmute yourself and give a talk.
Hi, can you hear me?
Yes.
Yes. I just got a question. When you explain about sample HIMI, so you say that this one is in your personal account, but here you only indicate relative path.
Oh.
So how this this Seagrass Mapper knows that? For example, if I have in my account, how can Seagrass Mapper knows that this name is coming from my account?
Thank you for pointing out. I forgot very important information here. When you are assigning, when you try to read your personal account, you have to give the full path to the asset, your personal asset. In this case, full path means users /Genki 007 / sample HIMI 1807. You get it? So, okay.
Yes, I understand.
So yeah, to give this in writing, and just to demonstrate this, hold on a second. Yeah. So this is what you should type in. Users, this section is your personal, is associated with your personal Gmail, Google account. And then the sample HIMI is an asset folder name. And then read it. After read by the Seagrass Mapper will just remain information after the last slash. Is it clear, Eligio?
Yes, thank you. Copy.
Okay. So I just explained another technique to read the, your personal asset information. Okay, stop sharing. Okay, Mikhail, I think you have a question. Please unmute yourself.
Yes, can you hear me?
Yes, I hear you.
Okay, I've just tried using different water column correction algorithms as you described, and I kind of got very different results. I can share my screen to show if you want.
Yeah, you can please share your screen.
Yeah, I'm curious as to 1 second. Okay. Right. So
is this okay? First of all, this is sample Nanao dataset.
Yes, the sample you have been using previously. So for the AI, have like this image, and for BRI, it's kind of in some areas it's similar. Like the yellow. I'm not sure what class is this. I don't really remember. But for the red class, it's almost completely inverted in this area. What can that be explained by?
Yeah, you see this difference, and this. So this is so it is important to know the accuracy assessment result. That's the only thing that you can rely on.
I see.
Yeah. So if I know in the case of Nano Bay case study, BRI works better than DII, as you can see in the accuracy assessment and the value.
It says that accuracy is around exactly the same, actually.
Oh, it's same. And I think in this
Yes,
exercise, you are using only 3 classes. Maybe it's the result may change if you assign the number of classes to 4.
That's what it automatically says with the data, though, supervised classification. Though I understand what you're talking about.
Yeah, okay. You need to uncheck supervised classification and then first, and then change the number of the class.
I see. Thank you.
Yeah, thank you for asking this question. So is everybody's trying the exercise this is the kind of something that we already did yesterday. Today I will be just giving details of each parameter settings. And tomorrow we will be breaking into several groups using the breakout sessions functions of the Zoom. And then we will be assigning the lead in each group, and we will be creating the, we will be working on different case study site. And yesterday, I didn't see any Chinese colleagues participating in this session. Now I see people from China participating in this session. Is it? I see 2 Chinese people participating in this session. Is this true? If you're from China, please raise your hand. I want to show some options using Seagrass Trainer if you are from China. From the ID, it's hard for me to understand if you're participating from China or not. Okay. Well, nevertheless, I think it's important to know that the Seagrass trainer has option to do the mapping. And let me introduce how it's going to work. Okay. So I'm right now logging into a Seagrass trainer. Okay, and I will be using this analysis tool. But right now I have no data set uploaded yet. But let's assume that I have, oh, okay. I have something here in the folder. But let's assume that I have every training data uploaded already into a one asset folder. And then I hit this analysis tool button. And here under the select option, you need to choose the data date that Seagrass trainer is looking for the image and the end date. Okay, let's set it to June 30th, the same month. And in this section, there is in this window, there is an atmospheric correction section where you have an option to mask land. I recommend not to check this box, mask for dark pixel, because this is, as I said, for very clear water, and this is option to execute atmospheric correction, and you can choose dark pixel. There is no near infrared model embedded in this section. Water depth correction, it's same. If you have depth data uploaded, you need to check this box, and if you want to mask area deeper than 10, you have to specify the depth. And then you hit run. And then the Seagrass trainer is giving order to Seagrass Mapper now to do the classification. You will be receiving emails from the system acknowledging the data order has been received. And once the data is ready to download, you will be notified by another email to download the data. So this is not an interactive way, but I just want to demonstrate that Seagrass trainer also can map seagrass or coastal habitat using this analysis tool. Okay. So I assume everyone is following this exercise, and tomorrow at the day 3, we will be breaking into different groups, and then work on your own case study site, and using your own data set or the data set you will be just creating during the hands-on session. So any questions about these classifications and accuracy assessment? Please raise your hand and unmute yourself if there is any. Sagawa-san, are you there?
Yes, I'm here.
Okay.
Mm.
So I understand there was this time lag issues about uploading dataset for,
Yeah.
and also uploading at the same time altogether. It's problematic.
Yeah.
So to improve this situation, it will take a lot of like engineering effort, or do you see any like idea how to improve the system?
Uh, you mean in the future?
Yes, in the future.
Now, it's difficult to say clearly.
Okay.
But we will consider. Maybe yeah, we will need to consult with you after webinar. But during this webinar, sorry, but we can not have a quick solution.
So you recommend us to, if we are doing this exercise tomorrow, uploading by team,
Yes.
Will be it will be better.
Yeah, I think so. Yeah, if we select order, I mean, not to all the people, but if you select several data, I think it's okay. And if you sometimes maybe it doesn't work, so in this case, maybe we try again. And after we check the data set, and yeah, we can check the data set from our side. So
okay,
if it's okay, yeah, we can do during this webinar.
Okay, thank you.